there, boys and girls. Welcome to another lesson of Mathematics Form 1. How are you doing today? Hope you are feeling good. My name is Susan Matthews and I am from SMK Putrajaya Presin 181. In this lesson, we are going to learn about a special kind of polygon called quadrilaterals. I hope you are ready for the lesson. You may want to prepare a notebook, pen and calculator to make it easier for you to take notes and do calculations during our lesson today. Let's begin our lesson now. Firstly, let's look at the learning objectives for today's lesson. By the end of today's lesson, you should be able to first, find the sum of interior and exterior angles of a quadrilateral. Second, find the sum of interior angle and adjacent exterior angle of a quadrilateral. Third, solve problems involving quadrilaterals. And lastly, solve problems involving the combinations of triangles and quadrilaterals. Are you ready for the lesson? Yes, of course you are. In the previous lesson, you would have learnt about properties of quadrilaterals and how to classify quadrilaterals based on the geometry properties. Do you still remember what a quadrilateral is? A quadrilateral is a two-dimensional figure with 4 sides and 4 angles. The word quad means 4 and lateral means sides. Let's look at the types of quadrilaterals that we have learned. First, a rectangle, which has 4 right angles. Opposite sides are equal and parallel. Let's look at the second shape. This is a square. A square has 4 equal sides and 4 right angles. Let's look at the next shape. This is a parallelogram, which has opposite sides that are equal and parallel. The next shape is a rhombus. A rhombus looks like a diamond. It has 4 equal sides and the opposite sides are parallel. Let's move on to the next shape. This is a trapezium. It has a pair of parallel sides. The last shape is a kite. 2 pairs of adjacent sides of a kite are of equal length. In the next lesson, we are going to learn about the interior angles and exterior angles of quadrilaterals. Please watch this video. I hope that you are able to see the relationship between the interior angle and the sum of the interior angle. Let me explain further, boys and girls. An interior angle is an angle inside a shape. In our previous lesson, we learned that the sum of interior angles of a triangle is 180 degrees. The quadrilateral is a combination of 2 triangles. Because there are 2 triangles in a quadrilateral, we can conclude that the sum of interior angles of a quadrilateral is 360 degrees. Let's look at the next screen. Observe the diagram and angles given. So, are you able to see the relationship now? Yes, I'm sure you can see it now. So, let's recall what we have learned. the interior angles in a triangle add up to 180 degrees, and for the quadrilaterals they add up to 360 degrees. Why is this so? This is because the quadrilaterals are made up of two triangles. Now, let's explore the relationship between the interior angle and its adjacent exterior angle. Let's see if you can still remember this. The exterior angle is the angle between any side of a shape and a line extended from the next side. Look at the diagram. As you can see, the interior and the adjacent exterior angle actually form a straight line. So, knowing that the sum of a straight line is 180 degrees, we can conclude that the sum of x, which is the interior angle, with y, the adjacent exterior angle, is 180 degrees. These angles are known as supplementary angles. Perhaps an example will give you a better understanding. In the diagram given, ABC is a straight line. Calculate the values of x and y. Let's look at the solutions. As the sum of the interior angle and its adjacent exterior angle is 180 degrees, we can find x by subtracting 180 degrees with 105 degrees, which is the exterior angle given in the diagram. X is equal to 75 degrees. Next, to find y. We already know that the sum of interior angles of a quadrilateral is 360 degrees. So, we can find the value of y by subtracting the sum of all the interior angles with 360 degrees. Hence, the value of y is equal to 105 degrees. Isn't that easy? Now, let's explore the relationship of the exterior angles of a quadrilateral. Please watch this video. From the video, we can conclude that the sum of the exterior angles of a quadrilateral is also 360 degrees. Let's move on. Let's watch another video which explains the relationship between the opposite angles in a parallelogram. From this video, we can conclude that the opposite angles in a parallelogram are equal. So, boys and girls, how does all this information help us in maths? Let's practice. Remember, practice makes perfect. In this practice, you have to guess the type of quadrilaterals based on the given clues about their properties. The first question. Who am I? My opposite sides are parallel and of equal length. My opposite angles are equal. My diagonals are bisectors of each other. Are you able to guess now? Yes, that's great! I am a parallelogram. Let's look at the second question. Who am I? My opposite sides are parallel and of equal length. All my interior angles are 90 degrees. My diagonals are of equal length and are bisectors of each other. Do you recall who I am? Put your thinking cap on. Awesome! I am a square. That was easy, right? Let's look at the last question in this section. Who am I? Two pairs of my adjacent sides are of equal length. One pair of my opposite angles is equal. Could I be a rhombus or maybe a rectangle? Let's think. Great job! Yes, I am actually a kite. That was fun, right? Now, let's look at the next practice. In this practice, we will look at how we can solve problems involving quadrilaterals. Without wasting any more time, let's take out a piece of paper, a pen and a calculator. Question 1. Calculate the values of x, y and z in the following diagram. Let's observe the diagram and analyze the angles given in the diagram. What can you see? What is the best method to solve this question? Recall what you have learned today. Let's see what the solution is. The diagram shown is a quadrilateral. Looking at the angle at x, we know that it is adjacent to the exterior angle, which is 110 degrees. We know that the sum of a straight line is 180 degrees. Now we can subtract 180 degrees with 110 degrees to find the value of the interior angle x. So, x is 70 degrees. Next, let's look at angle z. Angle z is an interior angle. We know that the sum of one whole rotation is 360 degrees. So, in order to find the value of z, we can subtract 300 degrees from 360 degrees, which gives us the value of z as 60 degrees. Marvelous! We have only one more angle to find. Why? X, Y, Z and 130 degrees are all the interior angles of a quadrilateral. And we know that the sum of the interior angles of a quadrilateral is 360 degrees. So, in order to find the value of y, we have to subtract the sum of all the interior angles. X equals 70 degrees, Z equals 60 degrees and 130 degrees from 360 degrees. Great! The value of y is 100 degrees. Did you get the same answer? I hope you did. Let's continue to question 2, shall we? In question 2, we are going to calculate the values of A, B, C and D in the following diagram. This diagram is a quadrilateral. A, B and C are all interior angles. The adjacent exterior angle is given for A and B. This makes it easier for us to find the value of A and B, as we know that the sum of an interior angle of a quadrilateral and its adjacent exterior angle is 180 degrees. Angle A is 90 degrees. We know this when we subtract 90 degrees of the exterior angle from 180 degrees. Meanwhile, angle B is 69 degrees. We know this when we subtract the exterior angle of 111 degrees from 180 degrees. We can now find the value of angle C, as we know that the sum of interior angle of a quadrilateral is 360 degrees. Add the sum of angle A, B and 78 degrees, then subtract the sum value from 360 degrees to find the value of C. C is 123 degrees. Now we are almost ready to complete the question. We can find the value of D, which is actually the adjacent exterior angle for C. We need to subtract 123 degrees from 180 degrees to find the value of D. Bravo! We succeeded in solving the question. The value of angle D is 57 degrees. Let's look at the last question in this section. The diagram shows a parallelogram. Calculate the values of X, Y and Z. Look carefully at the diagram and check what you know. We know that the opposite angles in a parallelogram are equal. That means angle Y is equal to the opposite angle, which is 50 degrees. Now, in order to find the value of X and Z, we have to understand that both X and Z are also opposite angles to each other. Using our knowledge that the sum of interior angles of a quadrilateral is 360 degrees, we can find the value of X, which is equivalent to Z. From this solution, we can see that X is 130 degrees. Therefore, angle Z is also 130 degrees. Now, let's look at other examples on solving problems involving the combinations of triangles and quadrilaterals. Example 1. Find the value of X and Y. Observe the diagram given. ACHI is a quadrilateral. BDEF is a parallelogram. We can start looking for the solution by calculating the value of X. X plus 80 degrees plus 80 degrees plus 150 degrees is equal to 360 degrees, as this shows the sum of the interior angles. From the working, we can see that the value of X is 50 degrees. Next, we can see that the angle CBG is opposite the angle DEF. We know that opposite angles in parallelogram are the same. So, the value of angles CBG is 60 degrees. Now, let's look at how to find the value of Y. CBG is a triangle and we know that the sum of the interior angles in a triangle is always 180 degrees. So, in order to find the value of Y, we just need to subtract the sum of angles CBG and BCG, which gives us 110 degrees. Next step is to subtract 110 degrees from 180 degrees. Yes, the value of Y is 70 degrees. So, did you manage to get the same answer? Do you understand the method to solve this question now? Great! Let's look at another example. I will give you some time to try this question on your own. In the diagram below, ACD and BCF are straight lines. Calculate the value of x. In this question, we would also be using our prior knowledge of lines and angles. In the diagram, CDEF is a quadrilateral while ABC is a right angle triangle. As ACD and BCF are straight lines, we can conclude that angle FCD is equivalent to angle ACB, which is 90 degrees, as they are both vertically opposite angles. From this, we can find the value of angle X as we subtract the sum of the interior angles of 60 degrees, 70 degrees and 90 degrees from 360 degrees. This gives us the value of x as 140 degrees. I hope you managed to get the same answers. Anyway, excellent job to all of you. Now everyone, let's look at the last question for today. In the diagram below, ABC is a straight line. The given angle BEC is equivalent to angle EDC. Calculate the value of x. Let's look at what we know. BCE is a triangle and BCDE is a quadrilateral. Angle CBE is an interior angle and angle ABE is the adjacent exterior angle. We can find the value of angle CBE by subtracting 180 degrees with 50 degrees. This gives us the value of angle CBE as 130 degrees. Next, as we know that the angle BEC is equivalent to angle EDC, so we can now label angle EDC as x. Now, in order to find the value of x, we need to add the sum of all the interior angles for BCDE. We will get 2x equals to 360 degrees minus 280 degrees. Therefore, 2x is equal to 80 degrees and x is equal to 40 degrees. Well done! I hope you have also managed to get these solutions. Boys and girls, we are almost at the end of today's class. Let's check the objectives of what we have learned today. Now, you should be able to first, find the sum of interior and exterior angles of a quadrilateral. Second, find the sum of interior angle and adjacent exterior angle of a quadrilateral. Third, solve problems involving quadrilaterals. And lastly, solve problems involving the combinations of triangles and quadrilaterals. I hope you enjoyed today's lesson. Try to do more exercises on your own. Remember, practice makes perfect. I love maths and I hope you do too. Goodbye and have a pleasant day. See you again in another lesson. Bye-bye.